Now let's start talking about each of these. Do we want to look at the ones we saw already?
Yeah.
And start talking about some of them? All right, the first one that we looked at, I'm going to turn the volume off on all of this, was Paul Smith and the hydrogen balloons. Now this is yours to explain. He's using more and more oxygen.
Yes. This Paul, when he was talking to us in the lab, or did you want to start? I
No, go ahead. No, you're fine.
Okay.
You used to do something like this.
Yeah, good.
Yeah. He was talking about observing this progression from deflagration to detonation. So where we have the mostly hydrogen, this is where we see that yellow fireball, that we don't have much of a boom, not much of a pot. It's just more all getting consumed. That fireball, I guess, is that deflagration or whatever.
Yeah.
And as that ratio of hydrogen to oxygen becomes more equal. So as we get more and more oxygen in there, we shift more towards that detonation, and that's that shock wave that we felt when we were in person. We felt that at the end when it was the 2-to-1 ratio because of and there was less of that fireball. So it's that movement towards a detonation that we're observing.
Yeah, because isn't it if he goes, because so he did 2-to-1.
Uh-huh.
If you go to 1-to-1, isn't that closer to at what point in time do you get towards bomb stage? And I think it's that. I think it's,
Yeah.
I believe once you start going further, because he won't do 1-to-1. I mean, he can't.
Yeah, he could. Yeah.
You get in trouble for that, I think.
So where does that fit in? That's a really neat demo and it's fun. I mean, the kids would enjoy it, but it doesn't really fit in my content that I know of. This one. And I mean, it's okay to have fun things. I mean, I would show this in a class. I would just for fun.
And the comment was made, maybe good for chemical properties of matter.
Okay,
Yes,
that's why he's a chemistry lecturer, so I figured it'd be
Right.
more chemistry than.
And I think really showing that if you're balancing reactions or something, sometimes it's nice to see, we see a lot of these example reactions when we're balancing, but sometimes it's fun for the kids to see, okay, yeah, we just balanced this. This is what it really looks like. And then showing something like that. So what those products might be, I don't know.
Okay. Reactive elements versus non-reactive.
Yeah.
I can see that.
Yeah.
I mean, I would only do it just for safety, talking about safety. Well, first for the wow factor,
Yeah.
and then to talk about safety. Why does he have hearing protection on? Why does he have eye protection on? Why does he have
A long rod to light it.
very long rod?
Doing this far away from us.
Yeah, that's the only reason I would do it. All right, so the vanishing water bill. Let's go ahead and explain. That was the second one. Hey, you look cross-eyed in there. Explain.
So here's what happened. I mean, and someone asked in the questions. I mean, clearly, all I did was go out and buy diapers. Okay, and you just cut it out, pull out in between. So I'm going to leave this as a fun thing because there's actually the chemical inside there. You can actually purchase from like Steven Spangler. Is that right?
Steve Spangler.
Steve Spangler. And you can use that. But inside diapers is exactly, it's similar. And so all it is a super absorbent. And so what you want to do is just put some down the bottom, kind of compact it in there pretty good. And someone asked, did I have to squeeze the glass or the plastic cup? I didn't. Other than to make sure it's kind of heavy at that point because it has the water in it. So I got to make sure that I don't let go of it and hit Steven on top of the head. And so you just kind of have to hold on to that long enough for that.
Okay, so is that a polymers? Is that what you do with polymers?
Yeah.
That's where that discussion fits in the curriculum-wise if you're teaching polymers, right?
Yeah, and you could go back to chemical properties. You can go back to, because you're talking about something that's super absorbent,
Mm-hmm.
and why is it able to hold that much water?
Okay.
That type of thing.
But it's as simple as, you bought literally diapers and you just cut the stuff out.
I just went out and bought. I bought swim diapers because I figured,
Probably had the most stuff in it.
yeah, that probably has some good stuff in it. And how many times you've seen kids get out, and they so. And
We've done something, use that same material when we're doing potted plants. So that helps plants and
keeps the moisture.
Yeah,
longer.
it keeps the moisture longer with us.
I used to always just get vermiculite from loading dock
Okay.
in chemistry,
Uh-huh.
but they don't use that for packaging anymore.
Yeah.
But okay, the next one we showed, and someone said that'd be a good investigation.
For comparing diapers
Mhm.
and their absorbency. Yep.
No, we did show the lighting and tea bag.
And someone asked the question, is there a better tea bag?
Yeah,
to
what
use?
tea bags? His were. I tell you what. Now, full disclosure on this, and this one they did in the lab. He did in the winter, and it worked really well. And then last week, he was going to show us it. He used the same tea bags. He brought in a handful that he had there, and none of them could he get to work very well. It did not work. He was wondering if there's just too much moisture in the summer, if humidity was higher and there was just too much moisture. Is what I think. This shows the best one that he actually did do here, but in the lab, they're in the classroom. But he did struggle this, but he was very proud of it before he had such difficulty. But he did say he did not use a full. You empty the tea bag, and he used like 3/4 of it, and otherwise it was a little too much. It was too heavy for liftoff, and he ended up trying to cut it shorter and everything, and just wasn't quite as impressive.
I do like the fact that his demo didn't work, and I've known Paul for a while. It's kind of cool that even for a guy that does this for a living,
Yeah, he's a professional demo guy. His demos is all lecture demo.
that his demo didn't work. I mean,
Yeah.
and that happens.
How does the diaper material being used for potted plants?
Relate to recycling or repurposing.
Oh man, we're getting dirty there. Um,
Yeah.
Quite soiled.
Yeah. Right. Yeah.
Sandy, I don't know if we have a great answer for you right this second.
I don't because if once you use a diaper, you pretty much throw it away.
Right.
I can't see somebody cutting it up and reusing it.
Well, you got fertilizer there.
You do?
Yeah, you do. I'm not doing that.
I'm not putting that in
I'm
my
not
potted
doing
plants.
it. Yeah. Not me.
Just curious. Tell you what, Sandy, why don't you do it outside and do a couple, and then let us know. That's a great question, though. You think about how many diapers go into landfills and everywhere. Are they just sucking water in, and are they having, you know what I mean?
Well, it has to break down over time.
Well, yeah. I don't know.
I don't know. All right, what's the tea bag teaching?
Like a convection. I think convection currents is
Not current, well, convections.
yeah, convection.
No people poo. That's right.
Yeah.
Farmers do it all the time when they pump septics. Not legally though. It's convection, yes.
Okay.
Not currents, but I would say
Not currents.
convection.
Yeah.
We're teaching convection.
Okay.
Yes.
Well, and I think that there's all kinds of videos out there of these. What do they call them? Are they called Chinese? What are they called? The
Lanterns?
Lanterns.
Yeah. Yeah.
You know, so these lanterns that go up in the air, and I'm sure kids go, "How in the heck does that happen?" Well, this is a cool way to look at how that happens.
An aspect of it, yes.
An aspect of that in the classroom.
Definitely an aspect of it. And in the classroom,
You just talk about hot air rising.
yes, hot air rising. So we can talk about the fact that it is heating up right here, the air above that. And then the thing is light enough at that point, since it has all that warm air there, it becomes less dense there. It does the hot air. Yes.
No, they said, so does hot air rise or does the cold air push it upward?
I would say the hot air rises.
Yeah, both ways. Oh, yeah, you can also show the clip from Tangled.
Yeah.
Yeah.
Yeah, that'd be good. I've heard it explained both ways, but I'm pretty sure it's the hot air rises.
That's what I want to
So
say.
unless someone can prove me wrong,
Well,
that's where I'm staying.
that leads us right to the convection current demo.
So if you were here this morning, you saw this demo.
Yeah.
So let's watch it and then we'll talk.
Oh, we're not going to watch all 4 minutes of it. This is a long one. We'll watch it start. And as this morning, we mentioned, if you weren't here this morning, the one beaker used a tea kettle, filled up boiling hot water once it was hot, and that's this side. The other is full of ice and water. Both of them need to be full all the way. And we just put a plastic tub of water on it. Nothing special, room temperature water in there. And then, as you can see, just regular food coloring. And this obviously is our convection currents demo. And it fits in so many different units that we can teach. And it's a great visual to help get the idea across. And so if we're teaching earthquakes and plate tectonics, well, what's happening here? We have our oceanic crust, which is more dense, that's subducting under our continental crust, which is less dense. And so it's going under. Similar to what we see here. We have these convection currents going in the mantle. And so that's happening there. We can talk about ocean currents as our icebergs, our polar ice caps are melting. It's sinking. That sinks and it pushes up, pushes the other water up out of the way. And so that actually, in our ocean currents are literally changing, which changes habitat and actual climates in some area as these currents shift places. And so they're actually changing the currents because of more cold water being put into the system. And so then obviously we could talk to our 8th grade. We have our weather. This is perfect for our weather, especially why that's one of the reasons we're using red and blue, right? When you talk about our air fronts, what's happening with our air fronts. We have our cold air and our warm air fronts. And if we leave this going, we can, what I do usually, I think I do it at the end of this one actually. Okay, I cut it off before I did it. My bad. What I usually do, I cut off the recording because it's 5 minutes long already, and I figured I'd lost you anyway. Is I'll drop some green in there, and it will kind of settle to the middle oftentimes. And we have the tall tanks. Sometimes we do it in, and that's where I started using the green. What are you looking for?
Keep talking.
Okay.
So I think another possibility with this demo, if you have some of the wireless thermometers, or if you don't have
Well, be
wireless,
careful because you cannot submerge that all the way.
okay, then don't use these. Okay.
Maybe the ones that we had this morning, the grill thermometer.
The grill thermometer.
I don't know if you can submerge them all the way or not, but we used to try to use little different stick-on ones and
We
stuff,
tried to
and
use
they
one
didn't work that way.
from aquarium tanks,
Yeah,
and they don't stick and they don't do very well. So the other veneer ones that are not wireless, they work really well.
you can put
And you can tape those on the inside. It's really cool to watch what happens as the hot and the cold air. So if you have one that's like towards the top of the tank, one that's in the middle, and then with this one I would have two down like by where that's hot and cold.
Mm-hmm.
And then you could look and see and watch temperatures. And what a great way for kids to predict what they think is going to happen, and for them to kind of have some skin in the game as they're doing that. Isn't gravity pulling the more dense, colder material down so the less dense material gets pushed up? I mean, clearly the water is being heated as it goes. I mean, that water coming up. So it is becoming less dense.
It's becoming less dense.
And the other one is colder. So yes, it is more dense.
We need to ask Robin to explain this.
Okay,
She's an atmospheric scientist.
right.
Let's do a video of her explaining how density really works for a higher level. Because I can tell you my opinion, but it's going to be my opinion. I
mean, based off of what I know, that makes sense.
It's logical what you're saying there, Lynn. But let's find out from an actual atmospheric scientist. We will contact her and have her do a video with us on that. We have other footage from her that we need to release anyway. But this demo, very visual. You can do it. You can have the kids do it. If you're in a hurry and don't want to run it at all, obviously we have the video. You can show that. But it's if you don't want to take the time to do it. But I like you said, I oftentimes have groups do this too. But that is a good one. We like that. This is the long one in real time. And then we also have a short that's only 58 seconds long. And basically, as you can tell, it's just running like 400 speed. And so it's
Yeah.
it's just running faster, and it's vertical, which is what kids see on their phones.
Mhm.
And so that's the other one we have for this. No explanation with either of these, but it sounds like you guys are wanting one, and so we'll do one. And so the next one,
And so with groups, can you do it smaller scale with smaller beakers and a plastic shoe container?
I wouldn't see why not. Yeah,
Yeah, of course.
wouldn't see why not.
Yeah.
Yeah, it'd have to be a smaller container too. If you're using smaller of these, smaller containers should work. And as I'd mentioned earlier, mason jars work perfect for this.
And Tupperware, right? I mean, just
Any plasticware,
Tupperware
yeah,
containers.
yeah, any plastic.
That would make it smaller.
But let's talk about the can crush next. Oh, we need to have the sound up for this. We need the sound up. This is Sarah's kids.
They're so loud.
Yeah, they were.
Yeah.
Very good.
All right, let's talk about what's actually happening here. I've seen a lot of teachers do this one. It's really easy to do. I guess we'll talk about how to do it and then what's happening. Quite simply, what we've done right here, you can see the edge of a hot plate. I just plugged in a hot plate that, okay, let's back to the other. Hot plate used empty cans, put just a touch of water in each of the empty cans, put it on a hot plate, and let that heat up. Then beside it, you have a pan or any container full of cooler water. Yeah, cooler water. I usually put like ice in there just to make a really big difference. And then the water here becomes water vapor. Water vapor takes, 4,000 times the space is liquid water, I think it is.
Wow. Okay.
Something like, if I remember right, we're going off of old memory, but something like that. I'll just say for definitely a lot more as it expands out. And so when you turn the can over in here, and what I always talk to students about, what we'll do is we'll calculate the surface area of that can. Because 14.7 pounds per square inch is at sea level, the average air pressure. And so I make them calculate how many square inches the can has to talk to how much pressure is pushing down on that can. Now, we will not be able to, we're not doing like a full vacuum on the can and stuff like that. We're not actually going to reach that level, but it's like, total like 500 pounds of pressure pressing on the can. No, we're not going to get to that level, but I'm all right with that. So what's happening is we flip that over into the cool water. The water vapor turns into liquid, takes up less space. All the air around is pushing on that can, so the air around the can crushes the can. Now, something else that happens when you lift it up, you pour out a lot of water. And that's where the question where's the water come from? A lot more water. Remember that air pressure we talked about. Yes, calculate the full surface area. Yes. That really depends on, to be honest, on the grade level. With like elementary students, when I did it with the younger elementary, we would just measure around and say, okay, if I cut this, it was a square, what would it be? And so then once I get to middle school level, we can do it. It's a cylinder, right?
Well,
So
and they were saying what a great cross curricular, and they could work with their math teachers.
Oh, definitely.
Right, that'd be a fun way to do it.
Definitely. And so that air pressure that we talk about, it is going in all directions everywhere. And so the pressure is pushing down on that water. Well, once we flip that can over, as soon as we flip that can over onto the water, see how I almost flipped over last time I drink my coffee. Oh, you can't even see that because I'm up here. Here, I'll stop this for a minute. There we go. Once we take and flip that can over onto the water, air pressure is pushing down not only on the can, crushing the can, it's pushing down on the water too at all times. And so that can at that point is a low pressure system. Water is being pushed into the can by the air pressure pushing on the surface of water. It's pushing it into the can. That's why we pour out more water than we even started with when we do that demo. Now, the one I always follow this one with that goes along with this in the most fun way ever. And if I'm doing it in class, what I do is I have a little PowerPoint, and we calculate how much the yes, the temperature will decrease. We calculate the mass, calculate the pressure. Then I'll ask for a volunteer. Now the video we have was actually done out on the sidewalk, and so it's not class. I will then crush a person.
Sidewalk science. We have a volunteer right here that we're going to do, and we're again talking about air pressure. You just have to hold this like this and not let the bag get pushed into there.
Okay.
You notice here, 1 second, here, breathe for a minute. You notice I said pushed in there, right?
Yeah.
Science never sucks.
Okay.
Okay, you got that, right? Science never sucks. So it can't get sucked into the tube. There's a fan in there. The fan is pushing air out, creating low pressure inside this system, right? And so it's putting low pressure in the tube. And so we're going to decrease the amount of pressure inside your system, the trash bag, and then we're going to see what happens. Get back, Tyler. But we didn't suck air out of the bag. All we did was create a low pressure system, and the air all around him was pushing in on him. Did it feel like a lot?
Yeah, it was a bit.
It felt a little intense.
Yeah.
Well, air has a pressure of 14.7 pounds per square inch, and you're a lot of square inches, so that's a lot of poundage.
All right. Christy says, so the water vapor cools off and turns to liquid water and takes up less volume. And that is correct.
Yes.
And that's what creates that lower pressure on the inside.
Yes.
Yeah.
Yes. 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 Yep, that's exactly what's happening. The water cools off, and so your water vapors turn into liquid water and creating a low pressure inside. And so, what was the rest of the question? That's absolutely right. What you said there.
It takes up less volume.
Yeah, so it's going to take up less volume. It's lower pressure in there because you don't have that bouncing around.
Yeah. And Tanya says, can also relate to how your lungs work.
And a nice connection for states of matter, too.
Yeah.
Oh, yes, yes. The crushing a person, one thing I always talk about, because I use a vacuum, put somebody in, obviously not their head. Also, the hair. Make sure their hair, if someone longer hair, make sure you pull that out of the trash bag, and then pull the trash bag up around them, and have them hold the vacuum hose like this. Otherwise, their clothes will start getting sucked into the vacuum. Yeah. But one thing I make sure the kids know, well, this is what we're going to talk about. One thing that's why I went like this, sucked into the vacuum. One thing I make sure I talk to them about when we hold up that vacuum, I'm like, all right, so what's happening? They're like, well, it sucks. I'm like, no. Science never sucks. We're creating a low pressure system in here by pushing air out, creates low pressure. The air around is pushing. And so science never sucks.
And what a great opportunity to bring in your principal and put them in the bag and suck it down. And I'm being very serious. I mean, what a great opportunity for them to be a part of your lesson and enjoy the kids kind of learning while you're there.
On campus groups, I've crushed a couple principals. Now, you do have to get the really big lawn and garden bags, and you have to watch shoes. I always have people take their shoes off before we do this.
Don't rip the bag.
Yeah. And I remember Franklin Middle School. Remember that assistant principal?
Oh,
he was a tall fellow.
Yeah, he was a big boy.
He wasn't fitting in there very well. I mean, we crushed him best we could. He wasn't fitting in there very well. And it's a really, really always moving. Yeah, that's right. Exactly. And so that I love doing that demo. The kids absolutely love that demo. Now, do be careful.
The lawn and garden bags, plastic ones.
Yeah, just the plastic. Go to Home Depot, Lowe's, Menards, whatever your hardware store is, and get the heavy duty bags.
Get the big ones. Yep.
Yeah, get the heavy duty bags.
Great. Good. Yeah.
Thank you.
Yes. Okay.
But that's funny.
That is funny.
But those heavy duty bags, and I'll use the same bag 100 times. I've done this at conferences before, and just like 100 times crushing people. Now, do be careful and sensitive to what students that you allow to volunteer.
Yeah.
because some of them kind of want to freak out because I tell you what, that's a tight hug.
No,
It's a lot of pressure. We're not pulling out of that because it's a lot of pressure on you at that point. And so, and I've had some people freak out just a little bit. And I had a classroom visitor that didn't know what I was doing, who never spoke to me again after this.
The other thing, and tell me if I'm wrong, you used to do this where you'd have them sit on the table,
yeah.
and you don't do that anymore, right? You have them sit on-
I still do.
oh, you do.
Yeah, I still do. Yeah, you have to hold on to them, and you have to be big enough that you know they're not going to fall. And I use that's why, I use a step stool for them to step up here.
Yeah.
But yeah, I still have them sit on the table.
Okay.
Yeah.
Right.
I've not lost anybody yet. But if you're not bigger than them, it's definitely something you got to be careful of.
Sure.
But I'm bigger than most kids, and so I'm safe. Except for like your kids.
Riley, yeah, he
Your
crushed my
kids
son,
were-
who's 6'4",
Yeah, I
almost 300 pounds.
crushed her. 290-pound football player kid. He would have fell. He would have crushed me. But that I do love doing this one to talk about air pressure. What do you say? I can't remember what I was going to say after that. But so after the can crush, I usually try to crush a couple of kids with this. It's always a really big hit and gets a nice conversation about pressure and pressure movement. All right, which one people want to do next?
Does any vacuum work?
Yes. I have this like little bitty 1 gallon shop vac that I used to use all the time, but because it's what I use to clean out furnaces and stuff, and that would work too. But we bought like a bigger one here for the lab, and I just always use it because it's bigger, it's fast. But yeah, really a small one would work. It's not that much air to pull out.
Yeah. Yeah. No, it's not.
I don't know if a dust buster would quite do it. It might not pull low enough, but it might not be able to go that low.
Yeah.
But yeah, I'm telling you, that's a really fun one to do. Hair raising. Hair raising. We're doing hair raising.
That's what I
Okay.
put on.
All right. We're going to hair raising next. Now, this next one is, unless you have a Van de Graaff. Oh, I should tell them about my nightmare the first time I did one.
Like get straight through your head. Or. Yeah. Straight out the back.
So I was worried that I was going to start getting zapped. That's why I'm like looking like a nut job.
I'm not gonna shock you. No, you go one at a time. That's all right. Oh, God. Isn't that weird? Yeah. You feel it coming. It's like, okay, don't do that. Oh. All right, now touch your hands to the table. No, it's not gonna shock you.
You see, she doesn't trust him.
Okay.
I don't blame you.
It's not gonna shock you.
She's smart.
Oh, wow.
Yeah, the hair just kind of dropped at that point. I would always make my students do this. I can't say that I've done this myself until now, but
And I bet I've done this 100 times. That was the best.
yeah, it's
I
pretty
mean,
good.
your hair
yeah.
it was a perfect day.
Yeah.
If you do this when it's really wet out or it's been
Yeah,
wet,
It does not work as
it
well.
doesn't work as well. So in the middle of the winter is a really good time.
Yes.
Anytime you know you're getting static clean in your shirts and stuff like that,
Yeah.
good time to do this.
Now, do you remember Roger who used to work at physics, retired? He used to do this part of his demo show. And he had told me, because I'd asked him, I'm like, well, some schools that you go to, there's, I mean, it's, you think a lot of, like the African American schools
Yeah.
and stuff, the hair, most of the girls are in braids and stuff like that. He said he was worried the first time. He said the braids will stand up.
Wow.
He said after that, which I was shocked. He said after that, he always tries to find someone with braids.
Huh.
Yeah, Florida. I don't know if you'd ever do this in Florida.
Maybe indoor. I don't know. I think
Yeah,
outdoors.
You
if
might
have
find some
good-
dry times.
Yeah. Yeah.
You always do it indoors. When are you doing it outdoors?
Yeah. Well, without open windows.
All right, so yeah, now we need to explain, like, what is this?
Okay, so hold on before.
Explain the Van de
So
Graaff,
the
man.
Van de Graaff generator is a. I wish we had a better down below, but it's okay. There is a. Can they see me? Because I'm doing this.
Oh, here. Oh, I gotta stop this
I don't
again.
know if
Sorry,
that's
having fun making fun of Sarah's face
Oh,
on the picture.
There's a bowl, a metal sphere on top, and inside there are these, it's fine metal combs. So I want you to imagine just literally like a comb. And that comb is sitting down like this. And then right next to it is a rubber band. And this rubber band goes around and around and around. So the best way I tell kids, I mean, hopefully you've all done this. If not, you guys are missing out on life. Where you run around and rub your feet on the carpet
Right,
and then touch
right.
somebody.
yeah.
So this is just a way that we are using the rubber band to rub their feet on the carpet really fast.
Uh-huh.
And then it's the combs are pulling the static electricity off of the rubber band and then making it go out to the dome that's on top.
Yes.
So this dome becomes very much negatively charged. And so then when Sarah puts her hands on it, that negative charge is, and you couldn't see this, she's standing on any type of insulator. Okay, so she's standing on some styrofoam that's wrapped around, but you could have it be a wood step, whatever. She was not standing on the ground. That insulator then doesn't let the electrons flow and go down through to the ground with Sarah, so they stay inside of her body. And so then after a while, you've got to get it going somewhere, and the hair is a real fine thing that eventually starts to stick up and separate because the charges are repelling each other.
Oh, they're talking about a thing you used to do. Because you would do a circle of students.
Yeah, I don't know if I would do this now anymore, now that I've learned more about this, but I used to have it where, so grab my hand.
I ain't touching you.
Yeah, I touched my hand.
Okay.
So we'd have people now grab Sarah's hand. So we would do this, and then somebody would touch the Van de Graaff generator over here. So if I'm touching the Van de Graaff generator, and then it would go through and eventually do all this. Now I would add a Tesla coil, and I would touch the Van de Graaff generator with the Tesla coil, and then it would give a quick jolt through, and you could actually watch the electricity move through the people.
Oh my gosh.
Now, I've seen it done, and I did it a bunch of times. Now I don't know if I would do it anymore. I think I'd be a little more worried about kids doing all that. But I would do it where they still are holding on, and then you could have that last person touch, and it would give an electric. Just so they understand that those electrons, I mean, we are becoming negatively charged.
Right.
Yeah.
And you've seen a video on Instagram with that. Yeah. It's amazing when you do that. Now, when would you teach this? Well, oh my gosh, you could talk about, if you're talking about electricity, if you're talking about electric current flowing, this is a great way to talk about electric current flowing through things. If you're talking about just electric charge on things,
Yeah.
great time to talk about electric charge.
No,
on things.
even thunderstorms and thunderstorm safety, because if the large thunderstorm comes through, this is what's happening, and this is what basically causes lightning. It's that static discharge.
Yeah. I mean, I think there are multiple ways to use this. Van de Graaff generators, they become cheaper and cheaper because they make them smaller and smaller, so you can get little desktop ones that are not very expensive now. They just don't put off as much static electricity. Yeah, open and closed circuits. Yes.
And electricity always going to the ground. So.
Yep.
Mhm.
So now, if you don't want to have a student touch this, and let's be honest, you'll see the full demo that we did in front of those third graders or whatever they were.
Yeah.
And Sarah got
Second grade.
shocked, and if you watch, Sarah got shocked by the cord that was running down below the desk,
Yeah.
He stood there and took it like a champ. Though.
and it had to hurt.
Yeah, it did.
I've done it enough times that I've had, like, if I was wearing a belt buckle and you put your hands on it and the belt buckle was up against the desk, it would do a discharge from the belt buckle to the desk. So you got to be real careful about what you're doing. But if you get a pom-pom and just put a pom-pom on top of it and start it, it will separate those out.
What I would put on it when I first started
Rapid
here, I'd never used one before. And I was very nervous. I didn't want someone to touch it because I didn't know what I was doing. I didn't want to kill somebody. Eventually, I let a principal use it, and I shocked the heck out of him. But what I got is a whole stack of those aluminum pie pans.
Yes.
The small ones is what I got. stacked them up on top and they just start flying off one at a time.
Yeah.
And then it's like we had a doll or something on there with the hair. Then like you said, the rabbit fur would start lifting up. I did that. Then finally, the next year I got brave enough and I had a group come, actually from my hometown here to campus. And I thought, well, I know the person has to be insulated, can't be on the ground. So I went into my shop, my workshop at home, and I grabbed a rubber mat. I thought, well, that should work fine. And then it just starts going off. And he looks at me. He's like, "Hey, Steve, should I be getting shocked through my feet right now?" I'm like, huh. And I looked down and I'd actually grabbed a rubber mat by my metal vise where I'd been drilling a bunch of metal. And so it was a rubber mat full of metal flakes.
Not what you want.
Well, for him, it was perfect. But, if it was a real person, it would have felt terrible.
A lot of times when you buy these, it comes with a second spear that you can that's
Yeah.
just on a stick, and that's great to use because it's usually a glass or a plastic stick that it's on. So then you can reach up and touch, and you can actually get the discharge from one to the other, and it's very visible. So if you turn off the lights, the kids can see that
Yeah.
spark going from one to the other.
And years ago, we haven't used it in years because we always used the plug-in ones. I have a crank one. It's over there in the lab.
Yeah.
It's like a crank one where you just have somebody crank it up and to charge it and use it.
And then I'm going to throw this out, and I want you guys to hear this. And this, I think Sarah and I both agree on this, and you do too, I'm sure. If you teach in a middle school and there's a high school anywhere close, like your middle school feeds
Yeah.
into a high school, go ask your high school teachers if you can borrow stuff.
They're excited to
They
like.
want.
I was elementary and I borrowed stuff from the high school and they were ecstatic to
Yeah.
let me borrow stuff because think about it, I was elementary. They're like, oh great, someone's actually teaching science today,
Right.
Because it wasn't
Yeah.
overly taught where I was.
right.
But they were always really easy to get. They were excited to let you do stuff.
I can't even tell you the number of teachers in my building, and we were a K-12 building, and I wasn't just helping elementary school teachers, I was helping ag teachers prep lab chemicals and things, and biology, and I helped all kinds of teachers. It was a wonderful thing. Everyone wants to help everyone, so sometimes it's just asking, like, hey, do you have some beakers? Do you have a Van de Graaff generator or something? And oftentimes yeah,
You'd be amazed.
It's easier than you would think.
And especially
Yeah.
something like that, something like a Van de Graaff that's only used typically
Yeah.
once or twice.
Right.
They would love for you to use it. Okay.
Want to do the wave machine, Sarah?
Sure. Yeah.
Made from duct tape, wooden skewers, and what else?
Wooden,
Balls.
Yeah, wooden craft ball things.
Well, I even put music behind this one.
I see that. It's fancy.
Oh, that was it. That's as long as it gets.
That is
19 seconds of fun.
yeah. That's just a really nice visual. I think when you're introducing waves and asking students, what is a wave? How do we know what a wave is? And explaining to them that it's that transfer of energy and that they can see that wave happening, but that each of those, I think, especially using those wooden craft balls, they're staying where they are, but that energy is flowing through them. Sometimes I know when I've taught waves with, especially with middle school students, we might, even if we think of an ocean wave, I think some of them at times are thinking that water is moving, that it's not just the energy flowing through there, that those water molecules are moving, and they're not. They're staying where they are. And so this is a really nice concrete way of showing that
The transfer.
yeah, that the
Yeah, it's
energy
just
transfer.
moving through.
That's what I like for the transfer. And I see people, we have seen these and actually have done workshops years ago where teachers were using gummies to make them.
Yeah.
We used wooden skewers. We made this because it's part of a loan program that we have. And so we have teachers, we wanted to build it so that they could use it and borrow it and not have to build one. And so that's why we used the skewers. But the first time I saw this was one of the workshops that we had taught, and we have teachers do the ones with gummies.
Mm-hmm.
So yeah.
But I thinking about what Sarah said about the water and waves, I'm going to guess if you ask a lot of kids about waves and about what's going on, they're going to think that the things are moving through there, and it's not just a transfer. And so I think something like this is a great way to go, okay, is that ball moving through? No, that ball is just riding and going in, and then it's moving on to the next. I think that's huge.
See, that's what I was getting ready to ask. I don't know how to explain that.
Let's see.
Why do waves come up on the beach?
Um. Oh, right.
Because I've been honest, I don't know how to answer that. I don't know how to explain that.
It has to be, and maybe this is something that, sorry, we're going to have to think, I'll have to think about this.
I know, this is a great
But,
question.
but it has to be with the slope that it's going in, right? I mean, eventually there's, it's a slope that's moving in, so
Mhm.
the water no longer can continue to go, it can't just move this way. It's got to go, it's being pushed up. And so that being
But
pushed
still,
up.
you're giving me horizontal movement when you say that.
Well, and someone else just
Is-
put on there that it's getting more shallow. as
Well,
we come
that
up.
is.
So we have that energy transferring. We have a lot of water.
Oh, it's
and then
the dumb physics, isn't it? It's the drag. As that goes through, that energy goes through, you get that drag on the bottom, which causes the top to fall over.
Due to the difference in the slope, the top of the water continues and the bottom of the water
wave.
drags.
Yes, it makes it follow. That's right. Oh
Yeah.
man, it's been years since I looked at that.
Yeah, that's
Thank
right.
you, Kathy.
That's awesome.
Yeah, I mean,
Yeah,
that's,
it's that physics stuff, man. It'll hold you down every time.
Oh gosh.
But yeah, because it's going up down till that energy gets
Yeah.
knocked over to the thing. That's right. It's been a while. Jay's all about that. But this is kind of a fun and easy demo to do, and like people had said, and we said and someone even said they did it in marshmallows. I've not done marshmallows. I had kids who do gummies because that's what the teachers wanted to use that I was working with. But yeah, marshmallows would work. Any sort of small mass on the ends would work fine. And so, but that's a fun one to do. But all right, what do we want to see next? What do we want to discuss? Now, we saw these earlier,
Mhm.
the radiometers. I love using radiometers for lots of things. I mentioned that in the earlier thing. If you're at an earlier session, do you have directions how to make a wave?
How to make the wave machine?
No,
Or
can you
just
explain it real fast?
how to
Yeah, we
the
did
wave
it.
machine? Yeah, the wave machine. We looked at it. Actually, we looked at a lot of different videos, I think. And I don't think we came up with a plan, but we thought, well,
Well, we
could
just
make
put the
these
tape
with
out. We put the tape out. So what we did, we put a
Yeah.
tape measure beside
sticky
it.
side up.
take that off and let them see you.
Oh, see my pretty face.
I do.
We took the duct tape. We got the good duct tape.
Yeah.
We rolled the duct tape out,
Right.
sticky side up. Then we put a tape measure beside it, and I can't remember how far apart we decided to go.
They said there's a lot of easy online.
Okay.
Okay.
Yeah.
All right.
So you don't have to go that.
Well, it's just I'll finish explaining real fast.
No, I'm just saying.
But we went every like 2 inches or something
Right.
like that, and no, that's what it was. The ball's end can't touch.
Right.
It was just far enough so the balls didn't touch is what we went. Just slightly wider than the balls themselves is what we went. We laid the sticks down and then we glued all the balls on and we ran that up.
We did that first.
Did we do that first?
Yeah, I think we spent some time. We
Oh,
glued them all
I
on
think you're
first,
right.
And
It's been a
then
couple years.
Yeah, I know.
We
And-
bought the ones with a hole in it, didn't we?
Yeah, we did. Yeah, so they sell the wooden craft balls with the one hole end. And
Yeah, we made a bunch of little bitty
glued those
dumbbells.
in. Yeah,
Sarah uses them still to exercise.
and then we laid once they were all nice and dry. Then we laid the sticky tape down and went however far.
If they actually touch, then you'll lose more energy going down there due to
Right.
the friction. So and that's what we did. We laid them where they just didn't touch, and we went all the way down.
Mhm.
Then we laid a piece of duct tape on the top facing
Yeah.
down, pressed it all together, rolled it up, and called it a fancy thing.
We do put a piece of like burlap or something over it, so as we roll it up,
It doesn't
doesn't
get
all
tangled. Yeah. Yeah.
Yeah.
All right. Next one. What one do y'all want next?
Let's.
Or the top.
Out.
The top.
Okay, we've done the
The top we did.
We'll do the cooking oil one.
You want it?
Since- Yeah.
Sarah, would you explain what this is from?
Well,
Just in case
sure.
someone wasn't here yesterday.
If you missed yesterday mornings, we have a virtual lab online about classifying matter, but we have a series, we videoed these Tyndall effect tests. So a Tyndall effect is a type of test that we can do for a heterogeneous mixture. And if the particles in a mixture are large enough, they will scatter the light. And when that light gets scattered, as it's shining through, it makes that solution appear to glow. So you can use just a regular flashlight, but we think you get better visual results using a laser. We're just using this a very cheap, I think it was labeled as a cat toy. It's just a really cheap laser that we shine through. But this is a mixture. It's like 200 mils of water and 200 mils of vegetable oil, and we placed it on a stir plate and let it go. Let it start spinning with a little magnetic stir in the bottom. And then we just shine that laser beam through, and it's a really fine dispersion of the vegetable oil as it's spinning in the water. And those particles are just big enough to scatter that light, and it makes it look like it glows. So
I think this would be a great one. When you were saying that, I was thinking to not let the kids know what it's in there. Do one where it just goes straight through.
yes,
So vinegar.
yeah, vinegar, for example.
Vinegar. If you put vinegar in there, you stir it and you shoot it. It goes right through, and it's just like
you can
nothing.
see the beam of light on the other side. So if we were looking at the backsplash here in the background, we would see that laser pointer going straight through.
And then to do one like this, and then go, why is this different?
Right.
I mean, that I think is a great way to start this whole, and let the kids just
Yeah.
be right or be wrong, and let them just kind of get to the point, and then you can start to hone them back in.
Mm-hmm.
This was physical properties.
Yeah, physical property. Yep.
Is the content area we're looking at on this, right?
Yes.
Okay. Okay.
Yeah.
But we could also use it for reflectance, scattering light,
Probably. Yeah. Yeah.
right? Because this is what's happening here, right?
Yes.
Scattering light versus
Absorbance versus
Yeah.
transmittance.
transmit. Yeah. Yeah. All right. Next one, Bill. You want to explain this?
Sure. I'll let them watch first.
Oh yeah. Wait for it. Wait for it. It even tells you to wait. If you know what's going on, put it in the chat. It's-
Boom. So this is a superconductor. And so what the setup of this is, it's just in a petri dish, and you can buy these little superconductor kits. That's the easy part. But what you need is liquid nitrogen. And so depending on where you are or who you're around, you may or may not be able to get your hands on liquid nitrogen. But what you do is you put this disc down, and the disc is a magnet, and then the little cube is the superconductor. So what you do is then you cool the magnet, so the magnet gets super cold. And when it gets super cold, that superconductor is allowed to float above, and it will just sit and rotate. And what happens is there's the repulsion between them becomes so easy because it's so cold that it allows it to sit on top. So the reason it fell off at the end is because it ran out of liquid nitrogen. Liquid nitrogen eventually evaporated, and it warmed up, so that was no longer allowed to keep that hovering above.
All right.
So there's a lot of talk of superconductors with regards to computers and all types of things like that. So great introduction in for a lot of that. So if the kids have never seen a superconductor, this is an easy way to see that.
All right. Any questions on that one? Nothing popping up?
No.
Well, while you're on liquid nitrogen, let's keep going.
Oh, geez. Yeah.
There's a question, where do you get liquid nitrogen? And one place, I know where I am, we're close to an ice plant. So that's a potential one place where you might be able to get a hold of some, is if you know someone that works in a local ice plant.
So what happened here is we had a racquetball, and if you've never seen this, kids love this. So you have a racquetball, the racquetball bounces real easy. And then if you notice, the little white container on the side, that's called a dewar. I had another racquetball in there it was sitting in the liquid nitrogen, so it was getting cold. So the one that's bouncing easy, the other one that's cold is very compact due to the fact that we have made it extremely cold. And so then when I throw that on the ground, it is like a glass base breaking. It just shatters and it goes everywhere.
Yes. So if you do get liquid nitrogen and you decide to do this demo, let's think about the safety there, please.
Yep.
It is like glass. It does go literally everywhere. I am half a room away from him and I was pelted.
Yeah.
It goes, so you need to make sure that it's not hitting, your students.
So, and the question about where you get liquid nitrogen, Sarah brought up the one point. You can also, if you're in rural areas, and there are large cow farms, a lot of times they will have liquid nitrogen because they store the cow semen in that.
Oh.
So they will have some that they might be able to get to you. Someone else in here said welding supply stores. So you just have to look around. But once again, if you don't, we have these demos and we have more of them.
We've done a bunch of liquid nitrogen demos. These are the only two I have up so far. Just because we've had a lot of projects going, but we probably have 30 more demos that are videos waiting for me to edit and put up.
Yeah, I know. Middle school kids would love that, wouldn't they?
Yeah. Mm-hmm.
All right. The next one's, we did this one already. We already talked about that. This video that's the second grade one we did. And we've pulled clips out of this. We did a little magic in science. Where, like I said, we had 80 second graders. They were second grade, right?
Yeah, second grade.
Okay, I thought you said 30 a while ago, but I'm like, they're
Second, third, they're all the same.
Yeah. But my country bumpkins know all about.
No, about AI, yes, they do. Yeah.
Yeah, Sarah lives there.
I live there too.
And so this is just a bunch of little demos that we did for that. It's just a demo show. A lot of these we've taken small clips. You'll recognize the one clip with the diaper
water.
stuff, the vanishing water. We've taken out of these.
But there's some really, if you take some time and look,
I'll pull more out eventually.
the one that Sarah does with you see
Dry
the bowl
ice.
right there with the dry ice is really cool and it's pretty easy to do. And I think everybody can get dry ice at this point.
I used to buy it at Meyer.
Yeah, Meyer has it, and
Yeah, that's exactly what I was going to say. Was Meyer will sell the dry ice.
Yeah.
You have to make sure you buy enough.
yeah.
Because it might shock you how quickly it sublimates.
But yeah, this one, tell them what you've done here since it's
So
showing.
this we put some dry ice in some water, and it's in this bowl. It's a metal bowl with a lip on it, and I have a really long thin strip of just fabric that I soaked in soapy water. So I think I put some Dawn dish soap in with some water and got it all nice and soapy. It has to be longer than the rim, and you gently rub it. It takes a few times to get going, but it makes like a big bubble. So you can see this. It's just a layer of the soapy film. And as that dry ice is sublimating in the water, it starts filling up with carbon dioxide and
Oh, it didn't work first time, did it?
yeah. There we go.
If you get your hand wet enough, if you get your hand
Soapy
wet,
enough and
soapy
wet
with
enough.
solution, then you can reach into it.
Yeah.
If you have a science night, this is a fun one to do. It worked the second time for you, didn't it?
Oh, I think I wasn't getting a lot of luck.
Why do I jump every time it pops?
I don't know. It's not even an
What?
explosion.
No, but I like jump every time it pops.
Yeah.
But it is neat to see this.
It is a very cool, and if you let it just run, the kids are just like, oh my gosh, it gets so
It
big.
does get really
it looks like a
big
big
if you do it.
mushroom by the time
Yeah.
it's done.
And then what Bill's doing off to the side is basically the same thing. Soap solution. We have the dry ice going here. Well, explain what your setup here, Bill.
Yeah, so down below you can't see is a, and we may redo this one, but it's just a 2-liter bottle,
Yeah.
and then it has a hole cut out, and then you add in the dry ice to the water. So basically, you're just getting the steam coming up, and now you have a soap solution in my hand, and eventually I'm going to, up on top, there's just paper towel that has a rubber band to that top part where the steam's coming out. And then when you take a soap solution and put that up on there, it starts to make soap bubbles.
Yeah. And that's just CPVC pipe. Yes.
Yes.
So Chris mentioned they haven't not been able to find liquid nitrogen, but has found that dry ice and ethanol or 91% isopropyl alcohol is cold enough to freeze flowers and gummy candies. So that's interesting.
So those are just CO2 bubbles.
And so and like I said, that's an hour long of just the different demos that we were doing there. A lot of them we're pulling out to make shorter ones up. But the Vortex Cannon, did we post that one yet? The Vortex Cannon would be an easy one to show.
That was towards the end.
Right here.
Oh, right there.
See?
Oh, yeah.
The Vortex Cannon, we've made a number of these. Actually, the first one I made was just using a 5-gallon bucket and some latex I bought online. But this one we used the 55-gallon drum or whatever, 35, I don't know, whatever size it is.
Side, yeah.
The trash can, and we glued. We can write up directions for that. Yeah.
Yeah. It's real easy.
Yeah, it's super easy. We used a fog machine, like from the Halloween supply store stuff, a fog machine, and that's just rubber that we've attached to the other end of the thing, and you just tap it, and you make your rings. And so that's the entertaining one, is you can shoot that all the way across a room. And it's really interesting you're talking about drag and stuff, because it's actually the drag around the edge that allows the ring to occur. All right, so what? Yeah, the trash cannon, like Trash Panda. I've seen people make those. Actually, Roger, from physics years ago, he had one. He used dry ice in a bowl, and he had made it out of wood. And so it was a big wooden box that he made with the hole in the front, drilled out in the front, big round hole. In the back just had the rubber on it. And inside he put a dry ice.
Okay.
But that's what Roger had.
I've never seen that.
We did that up at he did that up at Navy Pier
Did
when
we?
we set up there. But back in like Jiskey's first year. First time I'd ever driven in Chicago. What smoke did they put in?
Smoke from a smoke machine.
It was enough to set off fire alarm. I was
Yeah.
afraid Bill was going to do that one day.
Are you serious? I didn't know that they could do that.
Yep.
Well, it depends on what type of fire alarm it is. Some of them detect smoke and others do heat.
Mm-hmm.
Yeah, I have both in my house.
When
I
we
would if I lived in your
updated,
house. You're right.
when we updated our
What are
new
you saying about my
science
wife's cooking?
lab, we updated our new science labs, and they were much more sensitive.
Were
So
they?
a lot of times, even at sporting events, if they're cooking popcorn, the
It'll
fire
go
alarm
off.
goes
Oh my gosh.
and the fire alarm or the fire station gets alerted every time. And
The crushing person we did. And then the weight machine we did. Convection currents we did.
Can you do the cloud? Do the cloud in the bottle and actually show them the actual demo? Because you did it started like how, but you didn't do the demo.
yeah,
Oh, I didn't show the demo?
No.
Asked me if I can model the demos for them. And so we decided to put together this video series. And so this is the first one. So we are going to model some of the demos we do. Decided to start with a very easy one because I've had some teachers ask me about this. And it's the cloud in the bottle. We're just going to use a 2-liter bottle. I've done it with 1-liter bottles. I've done it with water bottles this size. I've done it with larger.
Jump to like here.
Then I'll ask the class, hey, do you see the cloud? Do you see the cloud? The other kids saw me like, yeah, I think I do. And we'll be like, well, not much for cloud up there, is it? Not very impressive, is it? Now it is. And so we have that nice cloud going on. But this is lower pressure now, since we took the top off. What happens when we have a high pressure front coming in? Let's talk the real world, right? High pressure, cloud goes away. High pressure can hold more water vapor. And so we clears up.
We clears up.
This again, pop it, and we get the cloud. We can do this several times. One thing to do, if we start doing it a lot of times, every once in a while you just have to kind of shake it up a little bit just to get the water flowing all around, right? Now, if you're doing this for a science night or something like that, parent science night at the school, then after a while, you want to add like a little more alcohol or a little more water. It's going to take a while before you get to that point, because as you can see, smoke rings. But as you can see, it's going to keep going and going. You can repeat this. And it's really nice to be able to talk about at this point. Very simple. The kids can do it. They can run this type of pump.
When I first came to Purdue, I went to a local high school. I was talking to the teachers, and he made the cloud in a bottle. They used a match and a 2 liter, and you squeezed it. And it was underwhelming. And I'm like,
Repeat that one more time. It was underwhelming.
yes.
Yeah, okay, good.
Underwhelming.
Every time you say that, I laugh.
Yeah,
Every time.
underwhelming. Because
What?
It's
fun.
underwhelming.
There's-
Because
Not overwhelming. It's
I
underwhelming.
know.
Is that not a word?
But I think
it's
it
a
is.
word.
But I wanted them to make sure they heard you say
Yeah.
underwhelming. It was not
It's-
very good.
it's hilarious. Yeah.
It-
It's no, you're true.
I
it's
like your term is
hilarious and
perfect.
true.
Okay. Okay.
It's
It's
just-
making fun of. I
it's
wanted to make sure they
unexpected.
understood.
When you say it was underwhelming, you just say it so deadpan that
Well, it
it's easy to
was.
miss.
He was excited about it, but I thought it was lame and boring because it's like, oh, okay, you could barely see any cloud in there, and so I started playing and trying to do things, and I figured out the bike pump, and I could get a bigger pressure difference, a lot better cloud. And of course, coming from the elementary, someone who has gotten yelled at by a principal, reprimanded in front of an entire class for having flames in the class, I had to figure out something for my peeps so they could do it. And so we started figuring out what to do and started using a little bit of rubbing alcohol, and it worked great. And I've been doing it for 20 years now.
So you put in there, and they can go back and watch the video.
A little bit of rubbing alcohol. When I say a little bit, I mean I don't. It's almost used a bad analogy.
About as much as you put in your.
Yeah, it's like mixing a rum and coke, you know. Sorry, and you encouraged me to do.
I did.
This
I
is
did
worse.
encourage you.
This is worse. But
We're adults.
yeah, that's right. You know, you just put a little bit of water in the bottom. Put a cup, 2 cups of water, whatever, and then just dump some rubbing alcohol in. I never measured it ever. Just dump some in. It'll work fine. You just need enough to evaporate so the cloud nuclei, because what's happening there, if you don't know, when you pump that up, high water pressure, a splash. There you go. What?
And we almost made it 2 days without Steve mentioning rum. Must be a record. Renee, you know him very well.
Moving right along. But what's happening when a cloud forms? You have the water vapor, right? And so the water vapor's in the air. It condensates. What?
Keep going.
Oh, I saw something about swim caps. It condensates. It has to have a cloud nuclei to condensate on, and that's where my teachers, before, they would use a flame, right? They would light a match or light a piece of paper, throw in there, and then they would get that particles for the cloud nuclei. Now the water vapor, as it evaporates, it actually works. Those what are the words, chemistry person? The evaporated water, the evaporated alcohol.
Yeah. Molecules.
Molecules, okay. They serve as the cloud nuclei point. So you have a bunch of things for cloud nuclei for it to condensate on. And that's why that works. It's beautiful. It's just great, and it's safe. And so I have these setups. I'll have like 5, 6 of them, and I'll have my class do it themselves. We have to talk about safety. We wear safety glasses when we do those. I won't even tell them, how to do it. I heard we can make a cloud in a bottle. We need to figure it out. And so we will start then figuring out what to do. Now, what I do is I don't tell them that I've doctored up. We're younger kids. I don't tell them that I doctored up the water that they're using. And I put a little bit of rubbing alcohol in it because that's just a little over the elementary head. Once we get to middle school, we need to talk about cloud nuclei because we need to expand that water cycle. So we talk about cloud nuclei at that point.
And every time I've seen you do it, I love when it starts off and you don't have anything in the bottle and you do it and nothing
happens.
And you do a great job of acting it because you're like, watch this, and then all of a sudden you pop it and everybody's like, what just happened?
Yeah.
And you're like, what, you don't see it?
Yeah.
And I'm like, I don't see
They're
it.
looking again, like, wait, what am I?
And
Use a
then
clean,
you're like-
empty bottle to be in a clean, empty bottle
Yeah.
with water in it. But there's not enough there's no cloud nuclei.
Right.
Nothing there to support that condensation. So all you get is condensation on the inside of the bottle at best. It's, again, underwhelming.
I think that's a great way to make that connection. Then when you add and then you explain that this alcohol's evaporated and it's getting in the air.
And that's what we do for older students. Yeah.
I love that.
For elementary, I skip that. I put a little bit of rubbing alcohol in there. That way it's isopropyl, whatever you call it. And that way it works beautifully for elementary. Once we get to middle, we can start talking about cloud nuclei. But then high school, definitely we have to talk about cloud nuclei. Yeah. Okay.
There was a comment that we missed that Chris mentioned using swim caps stretched over 5-gallon buckets for the air cannon. So 2 buckets with different diameter holes, and the students make predictions, and also has the students make their own by cutting a hole in the bottom of a plastic cup.
Yeah, I've done that in camps I've taught with a cup, not the swim cap. I don't need one. But I've done it with the cups and balloons.
Yeah, you said the narrow mouth part of a balloon off and stretch that over the cup as membrane. So yeah,
And then
perfect.
Chris said in the middle of my atmospheric unit, I have a mini unit on air pressure. I do tons of demos and experiments. I teach Bernoulli's principle as a part of this mini unit.
Yeah. Do you get the Bernoulli bags then for that? I love doing that one with the class. The Bernoulli bags, you can buy those at the science supply. They're the long, thin bags you can blow up with one good breath. And it's for years, I've had groups come to campus and it's like, hey, I'll bet you my lunch that I'll blow this up first. And they'll start. And then, of course,
Yeah,
you have to have them race. Exactly. And of course, I do it before them. All right, Can Crush talk about the laser balloon we talked about this morning. If you weren't here this morning, we'll let it run. It only takes a minute. We just turned the laser on a white balloon, and we stood there watching it.
And that's it. The answer is no. Right? Will a laser pop a balloon?
Well, obviously not.
No. Good demo.
Thanks.
Jake says, lift the kid off the ground, trash bag under wooden board.
Oh, yes.
Oh yeah, with you blow when the kids all get down there and blow.
Oh,
Yeah, we did that in the hallway one year.
Did you?
Yeah.
I have seen teachers do that. I've not actually done it.
Yeah.
I wanted to try.
There, that pause was just to show people they're the same size. And that's just a binder clip screwed down to a piece of wood to hold the balloon from doing what it's starting to do there. Oh, it still jumps.
Still jumps.
But obviously, there's a number of places we can use this. Can we stop it? Oh, hey, we got it. Obviously, absorbing of energy, the dark and light. We used it with the Earth Science Atmosphere or Earth Science unit this morning, talking about albedo of the Earth, absorbing energy. We can talk about, and even with the younger students, that's why we did that one video. We have them talk about wearing light clothes versus dark clothes in the summer, and assuming they're the same material and things like that.
This is not in our playlist, but what do you think about showing that as a demo?
Oh, yeah. When we pull it up,
Yeah.
is it public? Why is it not in the playlist?
It's
Oh, it's
yeah, it is. It's just not in our demo playlist.
okay. Do you want me to finish these here first?
Yeah.
Okay. No such thing as an empty bottle. That is just quiet, Joe. That is just a student worker and I going back and forth, and we made a video for the kids STEM degree with air pressure, and this is one I do with students all the time when we talk about air, to help prove that air exists, right? And so I will take a bottle, 3 or 4 of the 20-ounce pop bottles, and I will hold back one of them that I put a hole in the bottom of, and then we will put a balloon on there and blow up. See how Joe.
Well, and then wrap the top.
So you stick the balloon in, wrap around the top.
Perfect, like that. Eh? Make it a little bit more open,
Yeah.
so you can blow inside the bottle here.
Oh, there we go.
There we go, perfect. So I bet I can blow this balloon up faster than you can blow up yours.
I got a pretty big mouth, Joe. I don't know about that.
You ready?
No comments needed.
Let's do this. 3, 2, 1. What are you doing there?
Oh, I'm getting lightheaded, Joe. Wait a minute.
Look at that. It's
But if that bottle, I think, was getting a little used, but you can get that balloon totally filled in there. Put your finger over the hole, and it holds it blown up in the bottle. Where the other people cannot blow that bottle up. And so we talk about, well, what? There's no such thing as an empty
Right.
bottle. So if someone asks you if a glass is empty, tell them, well, of course it's not. It's full of air. And so that's what we talk about. It's not empty, it's full of air. So, yeah, I understand. Sana said that she does it in her atmospheric unit, and that's the place to do it. I would do this for elementary just to show that air exists.
Right.
Because they don't know air exists. And so
Just to, the one that the kid had on the left-hand side
has
has
a
a hole in the
hole in
bottom.
it.
And so when he's blowing, he doesn't have his finger on the hole.
Correct.
And then when he wants to keep it, he puts his finger on the hole to stop the air from going back.
You have the same amount of
Correct.
pressure on the inside and outside.
Yes.
Because air's pushing all around
Yes.
this.
I just want to make sure.
Yeah, well,
So Danielle said, wait,
I
did both
let
have
it
the
off a
hole?
bit, so it
No,
doesn't
no,
back
no, no.
down.
so when you blow the
Just the only one has the hole, and that's the person who's tricking everyone else. And no one else has a hole, so no one else can actually blow it up.
Yes.
And so it's pretty, I mean, if you start thinking about it, you're like, okay, so I'm blowing the balloon. If there's a hole in the bottom, I'm able to blow the balloon up because I'm pushing that air out.
Yeah.
And then I put my finger and it stops it. Where the other one, no matter how hard you blow, you can't push that air out.
Yeah.
Right.
And that's what I explain in this, that we go over again. So you're keeping that, it has the same pressure inside as outside because there's a hole, because it lets it go. So it's the same pressure, which allows you to blow it up. Mine's not being blown up because I'm pushing against all that air, and it's too much air pressure at that point.
And because I've seen it where they take a meter stick and you put a balloon on both sides and get it balanced.
Mm-hmm.
And then you pop one
Yeah.
and then quickly it,
hmm
and you're like, okay, that air did have
Yeah.
mass. It did take that
Showing
mass.
air has mass. Yep. Yes. Yep. And so there's that one. The drops on a penny. We'll show yours in a second
Okay.
because there's only a couple more, I think.
Yeah.
The drops on a penny. That is, we're teaching about adhesion, cohesion. That's part of our adhesion, cohesion lesson. So adhesion is a thing about adhesive. You use an adhesive or tape to stick things together or stick to something.
Mm-hmm.
So adhesion is the property of water to want to stick to something else. Where cohesion is cohesive. Let's be a cohesive group, all work together. Cohesion is the properties of sticking to itself or sticking together. And so we do the drops on a penny with that. And then after we do the penny, and I didn't do it for this short video, after we do the penny build, you want to explain where we go from there?
Yeah. Then if you've never done this, highly recommend that you do it with alcohol. Okay. And then quickly the kids will see the water or the alcohol start getting on the penny, but it gets very flat. And then it rolls off real easy. So it rolls off the side. It doesn't mushroom up like the water molecule does. So then you start talking about, okay, why?
And a couple things for that, if you're using the rubbing alcohol, you want to mind the percent of alcohol that you're using, because something that's a lower percentage of alcohol, we know alcohol can be diluted at times. There's 50%, there's 70%, 91%. That higher percentage, you're going to see that effect better.
Yes.
Than because the more water that's in there, the more it's going to exhibit those same types of properties of water.
And so typically you buy most alcohol, rubbing alcohol you buy is what, 70%, 75%?
There's 70. I'm looking at a shelf of it right
look
here
at
that's
91.
common to get in your local convenience store. But if you can get the 91,
Yeah.
that's going to really show those properties well.
Which cloud chamber did you
I think the one with the background.
background?
Yeah.
So can you do one thing before you do that?
Yes, I can. Probably.
Take off and let them see us.
Oh, I was ex-
So we used to do this, and I really like this concept. So you talk about water molecules, H2O. So if H2, so 2 hydrogens, 1 oxygen, everybody hopefully gets that. So if my head and my hands are the H2O, okay? So I have 2 stickies. So I have 2 things that can stick to other things real easy. So I can stick to, if Steve's another water molecule, I can stick to him and then I can stick to another one. That's that cohesion. But alcohol only has 1 H. And so when I have this 1 H, I can only stick to one thing. And so eventually what happens is there's not other things sticking, so it can't start to build this massive dome. It can only stick so far, and then that's when it falls off. And I think that's a pretty good way for middle school kids to start to see that. And then as they get into high school and get into chemistry, then it can be even further.
And then you
enhanced.
can start, I know Kara had added in too, if you don't have rubbing alcohol available, using a little bit of Dawn dish soap in the water and then doing those, that's fantastic, because then you'll get slightly different results from just using straight water. Also treating the pennies ahead of time. So rubbing the pennies with a soap solution or rubbing the pennies with oil ahead of time, and then trying to get that same result, either using water, how many drops of water then on those treated pennies, or how many drops of alcohol. And I think then we start to tie in maybe to higher levels, like with intermolecular forces and things happening.
Yeah.
So
A lot of great comments in there right now,
Yes.
talking about being done a scientific method intro. That's great. Yeah, I think anytime you get visual with the kids, an explanation, it's a plus. Okay.
And I know the other thing I'll say too, we had just done something with water with a younger group, and you had mentioned the Mickey Mouse ears, but you can also do that as a zombie walk, where you have
Yeah, that's what you did. with kids.
so your body kind of is the oxygen and it's the larger molecule, and then your hands are the hydrogens, and then have them kind of walk, and then it's a bent structure. So if you're walking like a zombie, you kind of have that bent structure like that too, and then it's more of a
Okay.
full body if you have a place for them to move around and things, and then you can also show them if they're keeping that composure, how water can, when they get close enough, they have to arrange themselves in certain ways, because the hydrogens only want to be near the oxygens. And then you can kind of see that when water is a solid and they're close enough together, how they can't stack right next to each other. It's a crystalline structure. So there's some other things you
That's
can do
cool.
with.
I like
Yeah.
that.
Yeah, she did that when we went and taught that at a field day last month. It was very well received by the students.
Like,
Cool.
yeah, the kids picked it up.
Someone just said play Thriller while you do this.
Yes, perfect.
Yeah.
Yeah, I like
That's
that
awesome.
a lot.
Love it.
Nice. This is the one you want?
Yeah.
Y'all gonna explain what's going on here?
Let's. Can we see something first?
I think we'll see something.
Yeah.
Oh, saw something.
I looked away. All right, I did see something at the bottom there.
Oh, there was one at the bottom.
Okay, so we're going to help you out a little bit. So what we're looking for, or what we keep saying we see, is what I'll call entrails. So
Contrast.
contrails, sorry, entrails.
Oh,
Sorry, it's almost 3:00.
No entrails, please.
Contrails. So what you're seeing is background radiation.
Ooh, there's a good one at the bottom.
So yeah, that's a real good one. So you're seeing background radiation. So here's what the system is. So the plate you're seeing is just a metal plate, and underneath the metal plate is dry ice, and a lot of it. And then inside this container, and the container's semi-sealed. It's not fully sealed, but it's semi-sealed. We've saturated alcohol on some felt on the top of this container. And so what we've created is
There's
a
a good
super
one.
saturated. Oh, that's a really good one.
mm-hmm.
Wow.
You know,
I got to stop for a second. That was awesome. So you have a super saturated bottom to this metal plate of alcohol. And so now we're able to see as the background radiation shoots through this alcohol, you're seeing these contrails.
when we say background radiation, we're talking about just the natural radiation that's around you all the time.
Mm-hmm.
Hey, there's nothing in here. We could show the other one that has stuff in there.
Oh, there was one.
Oh,
See that?
I did.
mine's delayed. That's why I keep.
Oh.
I'm after you. I've noticed that earlier.
All right, when we pull up the other one in?
Yeah.
Yeah.
The one with probably this one, the sources.
See that?
All right, Bill, explain this.
So inside there, on the left-hand side, well, we just went away from it. It's hard. It's moving. Straight ahead is a Brazil nut. Okay, and the Brazil trees have very, very deep roots. So as the nuts grow, they get radon.
Mm-hmm.
Okay, on them. On the left-hand side is a mantle. It's the cover. If you go
The old lanterns.
the old lanterns, if you go camping and you
Okay.
use those lanterns, that's the little that goes around and you light that. That has radiation in it as well, and you can see those. I mean, look at all those shooting off of that.
Yeah.
I mean that's what you're seeing.
Mm-hmm.
So when the kids love this, because if you talk about a Geiger counter, and they've all heard the sound of a Geiger counter, it's that clicking sound.
Yeah.
And so if you can get them back to the point when they hear that clicking sound, every time they hear that click, that is a piece of the background radiation or the radiation that's coming off of something hitting the
Vector.
yeah, it's called a Geiger-Moller tube, and it's hitting that membrane and it's counting that every time it hits. So that's that clicking sound. When it's clicking a whole bunch, there's a lot of radiation hitting it.
Mm-hmm.
If it's just clicking a couple times, then it's just a little bit.
It's Fiesta work.
Yep.
Oh yeah,
Well,
sorry.
Original Fiesta.
And that's orange Fiesta ware, and I mean that always blows my mind. But that a lot of
The
radiation, and it's the paint on it.
It was the
Yeah,
paint.
it wasn't the actual.
The paint was radiated, and so it emits a lot.
Yeah.
Yeah.
So I'm going to do it real quick. I did this demonstration once to a bunch of professors and people from that were out working in the world of chemistry, and this blew their mind.
Yeah.
I mean, they were like, they stopped doing their meeting and they all sat around because I had them already set up with nothing in them, and then all these sources that had it coming off. And I mean, they just couldn't stop talking about it. And these were people who do research all the time, but it is really a cool thing if you ever talk about radiation for kids to physically see it.
And Daryl Granger, he's done this with visiting groups with different rocks. And he uses clear cups. Instead of having a big plastic container like
He just
that,
puts a cup over it.
he has the clear cup that he then sets down over I don't
Still
remember
gotta
what.
be some type of metal plate. 'cause
Yeah, it
it's
has to
gotta
be something metal there, but I don't remember what. But yeah, I'd walked in and he was teaching this to a group using those clear cups.
But I mean,
Did a good job too.
this is just amazing to watch this video of this, the radiation. And we talk about radiation and people always, oh, and so why do they put the, lead when you get your teeth x-rayed and all that?
Yeah.
I mean, and so radiation's around us, and especially if you go up in an airplane, you're going to get more radiation.
A lot.
So I think it's just great for kids to understand really what it is. It's not something to be necessarily afraid of, but you just have to have enough knowledge about it to understand what it is.
Now we have about 30 more demos ready to upload. Well, we'll be ready. We have footage for, but we're not. So I guess at this point, those are the ones we have. Those are suggestions or ones that we have, and that's how we would put them in our curriculums. And let us know what else you want.